Welcome to Inheritance and Internals, Object-Oriented Coding in Python. My name is Christopher, and I will be your guide. This is part 2 of a multi-part course, an opus on object-oriented coding. Part 1 covered the class keyword and how you use it to describe classes, which are instantiated as objects in Python. It talked about attributes and methods, including the difference between those that operate at the class and object levels. It also introduced the descriptor protocol, showing how you can use the property and setter decorators to make a method behave like an attribute. This is part 2. It primarily focuses on inheritance, the different ways you can base a class on other classes in order to create hierarchical data relationships and reuse code. Along the way, there will be a bit more coverage of some of those magical special methods called dunder methods and attributes, showing you more techniques you can use to change how classes operate in Python. Depending on when you're taking this course, Part 3 may or may not be released yet. Part 3 covers more of the philosophy of object-oriented coding and how to write and design better classes. A link to Part 1 is in the notes below, and as soon as Part 3 is released, a link for that will be there as well. This part is primarily about inheritance. In it, you'll learn about inheritance, multi-level inheritance, multiple inheritance, more special methods, some of the classes in the standard library and how they take advantage of these features, and abstract base classes. The code in this course was tested with Python 3.11. Object-oriented coding in Python has gone through some changes over the years, and so the code presented here won't work in Python 2 without some changes. For the most part, I've stuck with general Python 3. There is the odd line here or there that uses newer language features, though. I'll point those out when they occur. Part 1 of the course showed you the syntax used to declare a class in Python and how the different kinds of attributes and methods work. When you declare a class, you can make it based on another class. This is called inheritance, amongst other things. And it's used to build classes that match a real-world hierarchy or to create code reuse. Everything in a parent class is available in a child class that inherits from it, meaning you don't have to write it twice. Inheritance isn't limited to a single level. You can have grandkids, great-grandkids, and more, as many levels as meet your needs. Not only that, but classes can have multiple parents, more than 2 even, allowing you to gain the functionality of several immediate ancestors. Additionally, there are times when you know what a class should look like but want to leave the implementation details to an inheritor. To do this, you can partially implement a class. This is known as an abstract class. The interpreter enforces the implementation. If the child class, sometimes known as a concrete class, doesn't implement everything, Python raises an error. All this fancy object-oriented coding isn't just for you. It's been taken advantage of in the standard library. The data class was introduced in Python 3.7 as a shortcut for creating classes that are mainly about their attributes, and the enum, a structure that is often a keyword in other languages, has been built as a class. Let's get started. Next up, I'll dive into inheritance. In the previous lesson, I gave you an overview of the course. In this lesson, I will introduce you to inheritance in Python. Inheritance is a way of structuring code where classes form hierarchies. A child class is one based on a parent and gains all the aspects of the parent, with the ability to override some of those features. This mechanism is useful for writing objects that reflect hierarchical relationships in the data itself and reducing the amount of code you write, keeping common code in a parent class and having one or more child classes inherit that code. Inheritance terminology has a fair number of synonyms. The class you inherit from is sometimes called a parent, like I did in the previous slide, a superclass, or a base class, with an abstract base class being a special case of a class that doesn't fully implement all its methods. It's a placeholder saying my children should have a method that does this. A class that inherits from a parent can be called a child, like I've been doing here, a derived class, a subclass, as opposed to a superclass, and the process of creating a child is sometimes known as extending the parent class. Why is there so much terminology? partially because there are a whole whack of programming languages that have object-oriented concepts built in, and each has their own take. The different terms from different languages and academic papers have blended together over the years. This can also lead to pedantic arguments like whether or not dunder init is a constructor. It isn't, but you shouldn't care. When a child extends a parent class, it gets all of the parent's methods. The child class can then do one of three things with the inherited method. First, it can do nothing, meaning when the method is called, the code in the parent gets run. Second, the child class can override the method, making a method of the same name. When the child's version of the method is called, only the child's version gets run, completely overriding the parent's functionality. Third is to extend a method. In this case, the child is also writing a method of the same name, but somewhere in the code it's invoking the parent's code. This can be useful if you want to add to the functionality but not replace it, allowing for code reuse. In Python, you can access the methods in a parent class using a built-in callable named super. This callable returns an instance of the current object within the parent's context. So super.method invokes the parent's copy of the method, allowing you to write a child version of that method that extends the parent's functionality. Let's go look at some code that uses inheritance. This is the aircraft class. It starts out with the keyword declaring it as a class. The special method for initialization, called dunder init, is called after the instance object is instantiated, giving you the opportunity to set initial values on the object. The arguments passed to the constructor are also passed to dunder init, so a common pattern is to store those arguments on the object itself. Remember, all instance methods need the self argument, a reference to the object you're interacting with. This code stores the make and model arguments on the object and also creates a non-public attribute called _flying. The takeoff instance method prints out a message and changes the value of the non-public attribute _flying to be true. And below it, the land method does the opposite. Let me scroll down. This is the plane class. The first thing you'll notice is the parentheses wrapping the aircraft class. This is how you denote inheritance in Python. Line 18 says that the plane is a child of aircraft. All the members of aircraft also become members of plane, but I'm not going to leave that alone. I'm going to mess with them. Plane's dunder init takes three arguments: make, model, and num engines. Recall that aircraft's version just takes make and model. I could just redo the two lines that stores make and model on the object, but instead I'm invoking the parent's dunder init. Line 20 does that using super to get at the object in the parent's context, and then directly calling its copy of dunder init, passing in the make and model. Even if you know the parent does nothing but store these two values, it's good practice to use super. That way, if additional code is added to the parent class, you get it automatically without having to worry about what the child's doing. And since the parent class, aircraft, doesn't have the num engines property, the plane class stores it. Using the terminology from the previous slide, plane's dunder init is extending aircraft's dunder init, keeping the parent's functionality but adding a bit of its own. Plane also extends the takeoff instance method. By defining a method with the same name, plane can modify the parent's behavior. On line 24, I use super to call aircraft's takeoff method, making sure not to lose its functionality, and then add some more code in the line after, with some extra printing. The land method is similar. Okay, let's build some flying stuff. First off, I'll create an aircraft object, so I need to import the class. And here's a Zeppelin, passing in the make and model. I can access the make attribute using dot notation and call its takeoff method. Let's get a plane. Significantly faster than the Hindenburg, the plane Tom Cruise made famous, an F-14 Tomcat. The make is stored on plane because I invoked aircraft's dunder init in plane's dunder init using super. And when I call the takeoff method, it also uses super, calling aircraft's takeoff, which prints out the first message, and then the extended code calls the gear up. Through the use of super, you can control what parts of the parent's code gets run, and you can also control when. Most of the time when you're extending a method, you'll invoke the parent's version first, but you don't have to. Sometimes you might want to change your object's state before calling the parent. The use of super merely accesses the parent context. You can call whatever methods on it in whatever order as you need. Inherited classes can also be extended, so you can end up with a whole hierarchy. This is a class object diagram. Each box represents a class and has 3 sections: the title, the middle section defining attributes, and the bottom section defining methods. The animal class on the top defines an attribute called name and has no methods. The mammal, bird, and fish classes each inherit from animal, gaining its name attribute. And then they further add their own attribute named feature. In this case, each class adds the same attribute, but that isn't necessary. At first glance of this diagram, you might rightfully think that feature could be moved up into the parent, but you see why it isn't when I show you the actual code that goes with this. The bottom layer here defines classes that extend mammal, bird, and fish. Each defines a method for itself. The none denotes the return value of the method. Notice how eagle and penguin define different methods. That's why you don't just want fly on bird, as not all birds can fly. The flying penguin would be a good name for a pub. Here's some Python that corresponds with that diagram. Animals dunder init takes the name argument, which it stores on the object. The mammal, bird, and fish classes inherit from animal and then each declare a class attribute describing special features for that group of animals. This is why it wasn't included as part of animal, because it's a class attribute. Class attributes were covered in detail in part 1 of this course. The short version is these are common across all the instance objects that are built from the class. At the third level, you see some classes that inherit from mammal, bird, and fish, each defining its own methods. Not only can you have multiple levels of inheritance, but a child can be based on more than one parent. That's what's next. In the previous lesson, I introduced you to inheritance and multi-level hierarchies. In this lesson, I'll show you how a class can have multiple parents. Python supports multiple inheritance, meaning a class can be a child of many parents. When you do this, you get a union of all the things in every parent you inherit from. Let's go look at some code. Okay, more classes about vehicles, and including flying vehicles. You just sort of run out of examples after a while. At the top here, I have a parent class having make and model attributes and start and stop methods. Let me scroll down a bit. Here is a car. The car is a vehicle, and as it doesn't override anything, it gains the dunder init, attributes, and start and stop methods from vehicle. It then declares its own additional method called drive. Scrolling a bit more. Aircraft is another vehicle. Similar to car, it gets its parent's members and adds its own method. And here, it's time to enter the future, a flying car. The syntax for inheriting from multiple classes is to comma separate the list of classes in the declaration. The flying car is both a car and an aircraft, which of course also makes it a vehicle through its grandparents. Let's create some objects. I've created a flying car and then called start. Remember, that method was declared in vehicle, the grandparent. And as flying car is a car, it can drive. And because it's an aircraft, it can fly. The same rules around super apply here as well. Everything from the previous lesson can be used in conjunction with multiple class inheritance. Multiple inheritance introduces a problem, though. You can get conflicts. Consider this diagram representing the classes you just saw. What happens if I extend the start method in car, changing its behavior? Now I have what is called the diamond problem, named after the shape of the class diagram. Which start does flying car get? The one from car or the one from aircraft, which aircraft inherited from the grandparent vehicle? Different languages deal with this problem differently. Let's talk about how Python does it. Python's answer is called the method resolution order, or MRO to its friends. When you look for a member on a class or object, Python looks for it in the following order. First, it looks at the current class. Then at the leftmost superclass. That's the first one listed in the inheritance declaration. That was car in my example. After that, it moves in order along the inheritance declaration. So after car, it would check in aircraft. If it still hasn't found what you asked for, it then moves up to the grandparents, following the same inheritance declaration order. Until, finally, it gets to the ancestor of all objects in Python, the object class. That name's not confusing. If you ever wondered where dunder init, dunder string, and similar methods are defined, if you don't define them in your class, well, they're in the object class. All classes in Python inherit from it automatically. So the short version of the MRO? The order of the class declaration statement is the order Python looks for things. Let's go resolve some method orders. Pardon the generic class names here, but sometimes an abstract concept makes it clearer. This file has 4 classes, A, B, C, and D. A is a grandparent, B inherits from A, C inherits from A, and D inherits from B and C. A, B, and C all have a method creatively named method. As D doesn't override anything, the MRO is what determines what happens. Before I show the result, take a second and determine what will happen when I call method on the D object. Okay, let's see if you were right. Importing D, instantiating, and calling D's method. As D doesn't override the method, the MRO gets used. The first class that D inherits from is B, so B's method is what was resolved. Python even includes a handy attribute that shows you the MRO for a class in case you aren't sure. Dunder MRO shows D, B, C, A, and then the ancestor of all, object. If you ever run into a tricky inheritance problem and you're not sure where something is coming from, dunder MRO can be helpful. A mixin is a special name for a class that doesn't have any attributes. You inherit from a mixin in order to add its methods to your class. This often serves the same purpose as that oh-so-common util.py file everybody has, where you put miscellaneous functions. It's the object-oriented version of the same. You build a mixin with generally useful methods, then include it in any class where you need those methods. Mixins are never instantiated directly, and you'll see them a lot in frameworks. For example, in Django, you might use one that adds database query features, and you'd mix it in with your database models. A quick tangent before I show you a mixin. Python stores the writable members of classes and objects in an internal dictionary. This dictionary is named dunder dict. The built-in vars function displays the contents of that dictionary on your object. I kind of glossed over something quickly at the top of this slide. Just what do I mean by writable? Well, things that you can change. For an instance object, that is its attributes. For a class, that's pretty much everything. The next couple sentences are a bit of a deep dive behind the scenes, and you really don't have to worry about it when you're writing classes. But methods are functions bound to a class using a reference. When you invoke a method on an instance, it's invoking the corresponding bound function on the class, passing in the instance. And because it's an object, you can actually modify the reference on the class and point it to a different function. You really shouldn't, unless you're trying to do something fancy, but that's actually how it works. Why do I bring all this up? Well, If you look at the writable things on a class, that includes the methods as well as any class attributes. For the purpose of the mixin I'm about to show you, the important thing you have to remember is that dunder dict contains the attributes of an object. There's an exception to all this, but I'll leave that to a later lesson. This file contains a mixin that does JSON serialization. The JSON mixin is a class like any other. It has methods and no attributes. The toJSON method uses the JSON module's dump_s function to turn a dictionary into a string containing JSON. What dictionary would that be? Well, the dunder dict contains all the writable members of the object, which are its attributes, which is what I want to serialize. And then to use it, the circle class simply inherits from the mixin. That means the radius and the color attributes can be turned into JSON. Likewise, the rectangle also inherits from the mixin, gaining the same powers. Let's use this. Importing. Creating a circle. Here's circle's dunder dict. And the same stuff, but using vars to get at it. Remember when I spoke about that writable stuff? For giggles, let's look at the class's dunder dict. This is a bit more complex than at the instance level. It contains two special attributes showing the module and docstring, and the dunder init method as a function reference. Like I said, more in implementation detail. Unless you're getting really tricky with your classes, you really don't have to worry about this. All right, and what you came to see, the mixin. The toJSON method serializes the attributes of the circle object. And of course, the reason you do mixins is code reuse. Here's a rectangle. And JSONified. Coming up, I'll lift the covers a little bit more and show you some internals of the class.